Welcome to Ask and Learn.
In this problem, we have a collar that's being pulled through a cord with a force of 300 newtons. We're also given the mass of this collar, which is 15 kilograms. And we want to find the velocity, which we'll call V2, when it reaches point B of the cord. Well, since we're dealing with forces and we want to find the velocity, we can use the work energy principle, which is given as the initial kinetic energy plus the work being done by the forces is equal to the final kinetic energy. Well, because this collar is initially at rest, then the initial kinetic energy is 0, since velocity is 0. So we're just left with the work being done by the forces is equal to final kinetic energy, 1/2 the mass of the collar times the velocity 2 squared. And this is what we're trying to solve. So now let's look at the work being done by the forces. We know that work is equal to force times distance. And here, the force is constant. So we have force times some distance that the collar travels. But we also have the force due to the weight of the collar, and that's in the opposite direction of the force that's pulling it up, because the weight is trying to pull it back down. So the work is negative. So, and the weight of the collar is just mass times gravity. So mass times gravity times the height that it travels in just the y direction. So what we don't know in this equation is the distance d that the collar travels throughout the entire cord. Well, we can break it up into segments and use the distance formula. You know, we can do A from the initial start all the way to the end, C, minus the little segment where it stops, B, times the endpoint, C. So total distance it travels is 700 millimeters, so divide by 1,000 to get 0.7 meters squared, and then plus in the x direction it travels 0.4 meters, and that's squared, and this is the square root minus the segment BC, and there it travels in the x and y direction the same, so it's 0.2 squared plus 0.2 squared, and that's the square root. So plugging all this into the calculator, the distance it travels is 0.52 meters. Now we can finally plug this in to our equation, and we can plug in all the other missing variables. So we have 300 for the force times this distance we found, 0.52, minus the mass times gravity, 15 times 9.8, and the height that it travels is 0.5, is equal to 1/2 m, which is 15 v2 squared. And so we're looking for v2, so let's solve for it. So v2 is equal to, so on the left side we get 82.5, and on the right side 15 divided by 2 is just 7.5. So we have 82 from the left side, 82.5 divided by 7.5, and then to get rid of the square, you take the square root. So then the velocity of this object is 3.31 meters per second.